Hello, 30-2s. Welcome to your unit called Rational Functions. Now, before we begin rational functions, what we're going to do is we're going to go back and we're going to review the essential skill for this unit, which is factoring, which we worked on in grade 10 and 11, but it's really, really important that we have this skill mastered before we begin this unit. So let's go for it then. Factoring. Well, we've got several different ways to factor that we've learned over the years. The first type of factoring is what we'll look at here, is looking for the greatest common factor, or the GCF. So when you're looking for the GCF, you're saying, okay, what is the largest number, the largest factor of 6 and 18? So 6. I factor a 6 out of the binomial, and I'm left with x minus 3. Next one, greatest common factor of 2x squared minus 12x. Well, the largest number that divides into 2 and 12 is 2, and from x squared and x is x. So what do we have left in our binomial? X minus 6. Okay, so I can also check my work by simply multiplying, distributing what I factored. I have to end up with what I began with. So you've always got a way to check your factoring. It's a good thing to try. Okay, let's try another couple. Well, greatest common factor of 15 and 5 is 5. Greatest common factor of x cubed and x is x. What do we have left in our binomial? Well, 3x squared minus 1. D, greatest common factor of 3 and 9. Well, 3, but I'm actually going to say negative 3 here, and then x. Why would I say negative 3? Well, what I want to do, and we're going to do a lot in this unit, is I want to notice that the x squared, which is my highest exponent I see, it's negative, and I don't like that. So what I'm going to do to rectify that is I'm going to make it positive by factoring out a negative 3. Negative 9 divided by negative 3 is now positive 3. X squared divided by x is x. 3x divided by minus 3x is minus 1. So this is called making my lead coefficient negative. That'll be an important skill. So those 4 examples were greatest common factor. These ones here, well, I want you to notice that there's 2 terms, x squared and 16. They're both perfect squares, and there's a minus in between. This is called difference of squares. So how do we factor a difference of squares? Well, what we're going to do is we're going to immediately make 2 binomials, and we're going to say this: the square root of x squared, x. The square root of 16, 4. And because it has to give us a negative 16 when we multiply this back out, that means one of the 4's is negative and one of them is positive. And the order doesn't matter. Look at H. Perfect square, minus in between, difference of squares. So 2 binomials, the square root of x squared is x, square root of 1 is 1, and 1's positive, 1's negative. The order doesn't matter. Difference of squares. Pretty quick. Here's another difference of squares. This one's a little more complicated because of the 4. But square root of 4 is 2. Square root of x squared is x. Square root of 9 is 3. Positive, negative, done. Now, J, what I need you to notice on J is this actually isn't a difference of squares. But the first thing I can do is take out a greatest common factor. That's an x. I have 4x squared minus 1 left as a binomial. Now, the 4x squared minus 1, that's a difference of squares. So that means I need to continue factoring. Square root of 4 and and x squared is 2x. Square root of 1 is 1. Positive and negative order doesn't matter. So that's a little bit more complicated than the others. So I always want you to check, can I keep factoring? Am I done the question? Then after greatest common factor and binomials, we get into simple trinomials. What makes these simple? Well, the lead coefficient is 1. So what we say is we need two numbers that multiply to 4. So they multiply to 4 and they add to 5. So they multiply to the constant term and they add to the middle term. So those two numbers sounds like 4 and 1 to me. So then to factor this thing, well, it's an x and an x because it has to multiply to x squared. And then we just use our two numbers, plus 1 plus 4, just like that. Next one. Well, again, it's a simple trinomial. So what do I say? Has to multiply to negative 30, add to negative 1. Well, those two numbers are negative 6 and positive 5. And it never hurts to take just a quick moment again and multiply this back out in your head to make sure you got the question correct. Okay, now those two are called simple trinomials. You can probably do them in your head. The next two are called complex trinomials. Now, they're not called complex because they're more difficult to do. They're called complex because of the type of answers they can give us. But the name is fitting because, yeah, there is more work to do. What we have to do on a complex trinomial is we have to say two numbers that multiply to the first and last term. So they multiply to 2 and they add to 3. Well, again, those two numbers are 2 and 1. So what we do here is something known as decomposition. What I'm going to do is I'm going to split up this middle term into the two numbers that we found. 3x is really 2x plus 1x. So I decomposed the 3x. Then what I'm going to do is I'm going to do something called some group factoring. So I'm going to put some parentheses around the first two terms and the last two terms. And I'm going to factor out of the first set of parentheses here a 2x. I'm left with x plus 1. Out of the second set of parentheses, I can factor out just a 1. And I know I've done this correctly because my two binomials are the same. So now I factor an x plus 1 binomial out of the entire line there. What am I left with? 2x plus 1. There it is. So a complex trinomial definitely got a little bit more work to it. Let's try one more. So we need two numbers that multiply to 6 and add to negative 7. Well, those two numbers are negative 6 and negative 1. Now, I'm going to decompose the negative 7. And it doesn't really matter the order. So I'll go minus 6x minus 1x. So I've decomposed the middle term plus 2. Then parentheses around the first two, parentheses around the second two, and there really still is a plus sign in between there. Just going to squeak that in. And then I factor each of the binomials separately. So I'm going to take a 3x there. Out of the second set of parentheses, the binomial here, I'm going to factor out a negative 1, which will then leave me x minus 2. I know I've done this correctly because my binomials are the same, so I factor an x minus 2 out of the whole thing, and there it is. Now, we don't get complex trinomials that much in 30-2. Definitely difference of squares and simple trinomials and just a basic greatest common factor are more important, but we will see more complex trinomials towards the end of the unit. So there's still important, but just not as important as difference of squares and simple trinomials. Now, the last thing I want to leave with here is something I talked about just briefly before. It's factoring to make the lead coefficient positive. So when I say that, again, I'm looking at this first example here, I notice my x term is negative. I want my x to be positive. So to fix that, I'm going to factor out a negative 1. What that does is the 3 now becomes a negative 3. I'm just going to put it at the back of my binomial, and negative x is going to become positive x. That's it. Now that seems a little strange, but you will see when you get into the very next lesson why I'm doing that. Okay, on B here, I want to factor out a negative because I want to make this negative 15x cubed positive. So I'm going to factor out my greatest common factor, negative 5x. Well, negative 15 divided by negative 5 is 3x squared plus 1. There it is. Okay, let's try 2 more. C, well, I want negative 9x squared to be positive. So I'm going to factor out my greatest common factor of negative 3x. Negative 9 divided by negative 3 is 3. X squared divided by x is x. 3x divided by negative 3x is negative 1. There it is. Okay, D. D. Put a star beside this one. I'll see this all the time. I'll see someone recognize that this is a difference of squares, and they'll say this is x minus 3, x plus 3. Okay, that is very, very wrong. It's close, but it's wrong. So here's what we're going to do. Let's factor out a negative 1. What do we get? Well, now the x squared is going to be positive. The 9 will be negative. And now that is a difference of squares. So I'm going to factor that x squared minus 9. Still keep the negative 1 out front. X minus 3, x plus 3. Now, maybe you're wondering why I didn't simply just factor it to become this. 3 minus x, 3 plus x. Okay, I agree that I could have, and that these two things are actually the exact same. They're equivalent. They just look very different, don't they? What you're going to see as you're working through this unit is what I did in blue by making that lead coefficient positive by factoring out the negative. This is going to help us as we go through the unit. So even though I agree what's in black is correct, there's going to come a point where you're going to have to make that lead coefficient positive to begin. Okay, there it is. There's your factoring review. Make sure you do your homework and you've got factoring mastered before you begin the rationals unit. Hope that helped.